Welcome to Deloitte Tech Talks. I'm your host, Raquel Buscaino, and I lead the Deloitte US Novel and Exponential Technologies team, where we sense and make sense of emerging tech. On today's episode, we're going to dive into the exciting world of ubiquitous cloud computing. We'll discuss cloud brokering, why the cloud sector is ripe for business model disruption, and how ubiquitous cloud computing might impact consumers and customers alike. I have the pleasure of welcoming David Linthicum, former Chief Cloud Strategy Officer of Deloitte Consulting LLP, to help us explore what that future of cloud entails. Dave, welcome to the podcast. It's really so great to have you.
It's great to be here. This is exciting.
So Dave, as a leader in this space, where do you see the future of cloud heading?
I think it's going to be around heterogeneity and differences in platforms. So companies kind of centralized on cloud computing, public cloud computing specifically, as the way of doing computing. Now it seems like lately it's the ability to move processes out to different heterogeneous environments, edge computing, mobile computing, even traditional computing, legacy systems, things that are on our desktops, all these different kinds of platforms that we're finally taking advantage of. And the core driver there is the ability to manage those environments and the ability to broker these resources. So within cloud computing, we've had this notion of cloud brokering for a long time. Ever since we had more than one cloud around, we're able to allocate and leverage resources and do so through brokering arrangements. So in other words, I need compute, I need storage. Okay, broker, where do I find that? And instead of just brokering cloud services, public cloud providers typically, we're brokering all kinds of services. Things that exist in our mobile computing, things that exist in our mainframe, data center, managed service providers, colocation providers, anywhere we can process stuff that we can connect to it via a network, that'll provide us with the least cost and the most optimized way to do it. And by the way, the greenest way to do it, the ability to use the least amount of resource and the least amount of power to get at the storage and compute that we need.
So Dave, it sounds like instead of just having a single source for your cloud computing, it's a multitude of sources, and it's almost like a marketplace of matching supply and demand, if that's a good way to say it.
Yeah, it's going to be the future of computing. Look at it. You're wearing a wristwatch, that can be a brokered resource. You're operating a desktop system, that can be a brokered resource. So the idea here is that where companies used to try to move to a single platform, become very homogenous, move to a single cloud provider, that doesn't seem to be the most optimized way to do it. And so people are deploying AI, they're deploying, different heavy-duty storage and process-intensive applications. And what cloud brokering is about, moving those applications on platforms where they're going to be most optimized. In some cases, that may be a public cloud provider. Other cases, that may be a mobile cloud provider that's closest to the point of data origin. In other cases, it's going to be edge-based computing. So the idea is that we're opening up within cloud computing the concept of the fact that it doesn't matter where a platform exists. It's accessible. We can broker it. We can manage and monitor it. We can deal with the complexity of it. We can really get to the point where we're finding the best, least cost, greenest routing capabilities or platform capabilities for whatever we need to do. So that seems to be a journey that we're on right now. It'll be interesting to see where everything heads.
Yeah. And you said that this has been in the works for quite some time, but what makes now a good time for cloud brokering to take place? And what are those driving forces that maybe weren't present in past years?
Oh, that's a great question. It's really kind of the connectivity has come about. So in the olden days, back we used to use ISDN and, even dial-up computing and slow broadband things, we couldn't reach all systems. And so the rise of cloud, kind of made it to the fact we could have broadband connectivities with a single public cloud provider. Now we have broadband everywhere, 5G, ubiquitous Wi-Fi, networking. So we can reach all these platforms at any time for any reason. And by the way, they're fairly reliable. We're able to manage them as platforms. And we're able to abstract or aggregate these platforms so they basically look like a single pile of compute systems, a single pile of data storage systems, any number of ways to do it. So what shifted was we've always had this brokering technology around, the idea that we could leverage highly distributed computing. Distributed computing is an old concept, it's been around since the 70s, but didn't have the network bandwidth to make it happen. So that was the primary drawback of moving it. Now we have the bandwidth, now we have the ubiquitous networking that goes along, which allows and enables ubiquitous computing.
Sounds like it's not just the visibility into what resources you have available, but actually being able to utilize them too.
Yeah, that's it in a nutshell. In other words, it's not as much to see the resource, but I need the profile of the resource. I need to be able to access and leverage the resource either as a storage system, a compute system, or perhaps a GPU, graphics processing unit, TPU, tensor processing unit, to support the AI-based systems. And by the way, it's able to secure access to the resource so I can have utilization of those resources without compromising security. Obviously, people are going to be a little concerned if I'm distributing their data everywhere and distributing the processing everywhere. What about my proprietary data? What about regulations and security issues? The reality is brokering management systems can layer those things. If you think about it, leveraging very distributed, very complex, very heterogeneous assets, but doing so through a single infrastructure that's able to leverage abstraction to make accessing those resources extremely easy. So for instance, if I'm a developer, I'm just seeing storage, and I'm seeing storage configured in any number of ways that I want to. I can see one virtual object storage system that may be spread across different physical devices that are maybe all over the world in some cases, if that is the most optimized way to do it, and those resources are the best and the greenest way to make that happen. So the idea is that it's not just providing access to very complex and heterogeneous systems. If you did that without management, it wouldn't help. It would make things worse because people would have to figure out how to code the various systems and native on these different providers. But the ability to have these brokering and management resources and leveraging these back-end systems that allows us to help to allocate, monitor, gain access to the most effective and efficient resources, but also leverage those resources in any number of ways. So we can see massive amounts of physical computing systems that could be abstracted into a single computing system instance. So it looks like one virtual machine that we're dealing with, which may be mapped to dozens of different processors that sit in different locations. Same thing with storage. And by the way, now that we're in the world of generative AI, same thing with GPUs and CPUs and LLMs and all these things that can be scattered across these various systems. Remember, in moving into generative AI, you're moving into very resource-intensive storage systems. Data is going to be needed in a high degree, massive amounts of processing is needed. And if you're going at it with just a single source of resources, there's no optimization that's occurring. This provides optimization to scale to those resource needs without necessarily hindering your ability to become more optimized and efficient. And, don't warm up the planet while you're doing it. And by the way, don't spend a lot of money while you're doing it.
Yeah. And so it sounds like when you say that green element, that sustainability side of everything, if we can more effectively manage our resources, how could that not be better off for the planet, for our environment, and this fight against climate change?
The idea of cloud computing was to be more green as well as more efficient. And of course, efficiency comes along with being green. The great thing about sustainability and money saving is they're bound, they're tightly coupled. So the more money and resources we're able to save, the greener that we're able to leverage these resources. And this is just basically taking it to the next level, because what we're saying is not only are the cloud computing resources going to be in bounds for us to allocate these resources in very optimized and efficient ways to be more green, but all resources, ubiquity of computing, the ability to have anything that stores a process or anything that stores data to a logical limit. Obviously, you can take it to a ridiculous level, but the ability to abstract and leverage those things as we need them. So we're in essence not wasting resources. We're not running systems that are only at 3% utilization, which we're doing right now in data centers. In essence, we're leveraging resources we already paid for. They're already burning watts. They're already providing a certain amount of CO2 emissions, but doing so in a more optimized way. And so that really would be the ultimate in sustainability, resource utilization, and the ability to get more economy and more value that can be returned to the business through the use of this technology.
And you mentioned for the businesses, what about for consumers? Could I, as an end user, as a customer, right, do I have agency to potentially receive some value from the processing power that might be left over on my devices, on my smartwatch? Is that a future we see?
I hope so. So companies, they buy millions of dollars of processors and storage every year, the ability to leverage whatever you need. And the thing is, if we're owners of those systems, we're able to configure them to be leveraged through these environments. And so it is an opt-in thing. Most of them are going to be known environments. We know where they are, what they do, things like that. We could have a future world where people are able to rent out their processing, basically by making it available to a broker that's able to, in essence, resell the system to someone who don't know. And it becomes kind of a resource that's shareable, very much like a car share service. And there's a certain amount of value that comes from that as well, as long as you can't turn that into some sort of a malicious threat. But most of this, I think, initially is going to be people who will opt in. It's going to be more traditional computers that we have sitting around a data center, even sitting around our homes.
It sounds like cloud brokering is at its core a business model shift, one that, for all the reasons you mentioned previously, drives value to consumers and customers. So if cloud brokering does come to fruition, what else can we expect to see as byproducts of this business model shift?
You got to have security and governance that's part of this. And the good news is we're pretty good at doing distributed computing security, but the bad news is there's fewer people who are walking the planet who really can execute on this. So it's a matter of also increasing the talent pool, becoming more security aware. And the reality is that security has to be built in every aspect of this. Security can't be an afterthought. It has to be systemic to these environments. Brokering systems have to be secure and governed.
As we shift to a world of ubiquitous computing, what does that mean for legacy computing? Is it an all or nothing game? Is it a transformation from one to the next? Is it coexistence of both? Can you speak to whether or not this is a revolution or an evolution?
Yeah, I think it's a matter of just not shutting things down just for shutting things down. I mean, 10 years ago, everybody was making the declaration that they're cloud first and they're going to shut down their data centers. That's not going to happen. Those things have a role, probably have less processing and less storage on them, but they become utilized really as kind of part of the mix. And so, and certain processing and certain patterns of application development, certain things will run well on these legacy systems that we can reach. So they become part of the ubiquitous pool. They have a profile, they have a participation, they have a certain pattern of application, certain storage system that they can leverage. And the idea is that we're going to have these big brains in front of these systems that are going to work with developers and work with people who need to utilize these resources to find the resources that they need. And in many instances, those are going to be legacy systems. You got to remember, for the last year and a half, we've seen a tremendous amount of repatriation where people have moved from clouds back to some of these on-premise systems because the cost of hardware and software has dropped significantly in the last 5 years. And they realize they're going to get a huge business benefit from running on-premise on this hardware that we own and the software that we own, versus on the public cloud providers, which we didn't own, but cost a lot of money. So it's basically automating that process, but doing so in a dynamic way. In other words, we have a processor and application that we release out into a ubiquitous network of computing and basically picks the platforms that are optimized for those systems. In many instances, it's going to figure out that the on-premise environment is going to be cheapest way to run that stuff. It's going to have least amount of power consumption and the most business benefit that comes back. And so it's going to automatically make that decision for us. And therefore, there's no, big projects and lifting and shifting everything into the cloud and going oopsie daisy and then shifting everything back to on-premise. Because we made a mistake in moving an application in a data set that wasn't quite really kind of designed to run on a cloud. Unless you make the investments in changing the code and all those sorts of things, there's a lot of under-optimized things we've done in the last 10 years. And so this will fix some of that, not everything. But the idea being is that every thing that we own is going to be a participant in this network. Everything that we own actually becomes the cloud and has the potential for providing benefits to the business. So it's maximizing what we have and the ability to leverage other resources such as cloud and managed service providers and colos as we need them.
Yeah, which is a compelling case to say, hey, listen, it's about utilizing and making the most of what we have rather than go out and getting something new. Because to your point that you mentioned earlier, if you're at 3% utilization, that's a lot that you're leaving on the table.
Yeah. And, I live in Northern Virginia, and this is the center of the universe where it comes to data centers. There's something called Data Center Alley, which is, probably 100 different data centers that are along this big path. If you would go into any of those things and check the utilization of a typical server, it may be less than 5%, just because they're not utilizing it to its fullest extent. Because it doesn't need to be used to its full extent. It's running one single application, one single database. They need to have the capacity on that system to allow it to dynamically scale up as processing load increases and scale down. But average, it's going to be way underutilized because it has a single purpose that's assigned to that system. This is about assigning multiple purposes and providing better shareability. And you think about how to do that within cloud computing, the ability to leverage multi-tenancy, the ability to leverage massive amounts of compute and hardware resources as single amounts of resources. This is in essence taking that to the next level. The ability to extend it out to everything that we own, everything that we control, again, for a larger business benefit.
My mind is just blown in so many ways, and I'm excited for this future that we're talking about. But maybe I'll turn it back to you and say, what makes you most excited when it comes to the future of ubiquitous cloud computing? What's really something that you're looking forward to if we realize this future?
Well, I've always been into this game because of the efficiency of resources. I knew for a long period of time and started thinking and dealing with cloud computing back in the 90s that we have this thing called the internet, and it provides access to other systems that are outside our direct control that we're able to leverage and become a shareable resource they're able to share among different entities. So I never liked the idea of buying a piece of hardware and a software, support a particular application, plugging it in the wall and forgetting about it. And we did that for every application and database that we needed to build. And that was the way you build systems. And normally you started a company, you had to buy a data center, put systems in it, things like that. So cloud computing allows you to punch above your weight, but also allows you to provide better shareability. And so the shareability promise of cloud computing has always been there, but it's not always going to be the answer. It's not always going to be the least expensive process to move in, and it's not necessarily going to be right for every application. It is the ability to find any piece of data at any time for any reason, and the ability to find access to the resources and leverage them at an almost fully optimized way. It's not going to be completely optimized, but just moving from probably 5 or 6% optimization to something that's be at 90 to 95% optimization, and the amount of business benefit that come back from this. So businesses would be able to re-engineer themselves to take advantage of innovations that are coming along, take advantage of the scaling, take advantage of the business opportunities of this. And it's thinking differently in the fact that we don't necessarily have to own everything that we run things on. And so we're able to use the loads that we have, we're able to broker it, we're able to manage it, able to deal with the complexity of these situations. We're able to do this in a secure way. And it provides our businesses to scale, but scale with less impact to the budget, less impact to the planet. And I think that's a good thing.
It's about optimizing resources to maximize business value at its core. It sounds like there's definitely some milestones along the way. But really, Dave, I just can't thank you so much for an incredible discussion on the future of cloud, what an ubiquitous cloud future looks like. I mean, it's truly incredible. So thanks for sharing all your knowledge.
Well, thanks for having me. It's great to share with you.
To all our tech-savvy listeners out there, if you enjoyed this episode, please share and subscribe. And if you'd like to learn more about the future of cloud, you can follow myself and Dave to stay up to date. Our socials are listed in the episode description. Thanks for tuning in, and I'll see you on our next episode. Until then, stay savvy.